Good morning. In this session, we are going to see about the topic radiation from the subject heat and mass transfer. Radiation heat transfer. Conduction and convection modes of heat transfer are related to the nature of material and the presence of liquid motion among their things. Radiation is characteristically different from other two mechanisms. The thermal radiation is the electromagnetic radiation emitted by a body as a result of vibrational and rotational motions of molecules, atoms, electrons of the substance. It is a radiation figure. In this we can see a conduction, radiation and convection areas. Radiation heat transfer. How the radiation occurs, we can see from this diagram. From the hard object, that is solid object, the radiation inside the vacuum chamber, there is no conduction, no convection, only radiation occurs. From the human thing, the radiation can occur between two bodies separated by a medium colder than both bodies. It is an electromagnetic wave spectrum. The radiation is the energy emitted by a matter in the form of electromagnetic waves or photons. It is also called as photons. Gamma rays, that is a nuclear reaction. X-rays, that is a bombardment of metals with a high energy electrons. Microwaves, that is a special type of electron tubes. Radio waves, that is excitation of some crystals or flow of alternating current through electric conductors. Thermal radiation emits as a result of vibration and rotational motion of molecules, atoms and electrons of the substance. That is a thermal radiation is 0.1 micron level and to the 100 micron level, and the light spectrum is 0.40 mu microns to the 0.76, and solar radiation is 0.1 to 3 micron levels. Radiation is propagated at the speed of 3 into 10 to the power 8 meter per second. The formula is wavelength and the speed of propagation and the frequencies. The electromagnetic radiation is a propagation of collection of discrete packets of energy called photons or quanta as proposed as Max Planck. Here E is equal to the Planck's constant is equal to hc by lambda, that is Max Planck. Energy of the photon is inversely proportional to its wavelength. Therefore, shorter wavelength radiation possesses larger photon energies. It is no wonder that we can try to avoid very short wavelength radiation such as gamma rays, X-rays, since they are highly destructive. Thermal radiation emits as a result of energy transition of molecules, atoms and electrons of the substance. The electromagnetic radiation emitted by the sun is also known as solar radiation, that is 0.3 to 3. The radiation emitted by the bodies at a room temperature falls into the infrared region. Bodies start emitting noticeable visible radiation at the temperature of above 800 Kelvin, that is a tungsten bulb is 2000 Kelvin. Ultraviolet radiation is a 12% of solar radiation is in the ultraviolet range. It kills microorganisms, that is ozone layer, blankets and absorbs. It is a wavelength range of different colors, namely violet, blue, green, yellow and orange and red. Radiation emitted by bodies at a room temperature is the infrared radiation, that is 0.76 to 100. Ultraviolet radiation is 0.01 to 0.4. Visible proportion of the spectrum, that is 0.40 to 0.76, and the microwaves and radio waves occupies a higher wavelength region. A surface that reflects all the light appears white, while a surface that absorbs all the light incident on its appear black. that is a visible radiation occupies a very narrow band. Snow and white band reflects the lights and thus appears white. But essentially, there are black or infrared radiation since they strongly absorb a long wavelength radiation. The color of the substance depends upon its ability to reflect certain wavelengths. Spectral transmit of glass. Glass transmits over 90% of radiation in the visible region and is practically opaque to the region, that is radiation in the lower wavelength range. But the entire radiation emitted by surface at room temperature falls in the infrared region. Glass allows the solar radiation to enter but does not allow the infrared radiation from the interior surface to exit. This causes a rise in interior temperature, and the sun energy passes through the car windshield. The energy radiates from the car interior cannot pass back through the windshield and the car warms up. It is a greenhouse effect. In the greenhouse effect, we can see the radiation from the sun. Black body radiation. A black body is defined as the perfect emitter and absorber of radiation at a specified temperature and wavelength. No surface can emit more than a black body. A black body absorbs all incident radiation regardless of the wavelength and direction. The Stephen Boltzmann law, the radiation emitted by the black body per unit time and per unit surface area is expressed as the value of Stephen Boltzmann constant into T power, the unit is watt per meter square. The temperature should be kept in a Kelvin. This is also called as a black body emissive power. The spectral black body emissive power or monochromatic emissive power is the amount of radiation emitted by a black body at the absolute temperature is a T per unit time per unit surface area at a particular wavelength. The Planck's distribution law. The relation for a spectral black body emissive power is known as the Planck distribution law or expressed as C. The formula gives a magnitude of the emitter energy at each of the wavelength which comprise the whole radiation. The emitter radiation is a continuous function of wavelength. At a specified temperature, it increases with wavelength, reaches a peak, and then decreases with the increasing wavelength. At any wavelength, the amount of emitted radiation increases with the increasing temperature. As temperature increases, the curve gets steeper and shifted to the left to the shorter wavelength region. A larger fraction of the radiation is emitted as shorter wavelength at higher temperature. The wavelength at which a peak occurs for a surface specified temperature is given by Wien's displacement law. The value of it is 2897.8 Kelvin. Emissivity. Emissivity of the surface is defined as the ratio of the radiation emitted by the surface to the radiation emitted by the black body at the same surface temperature. The emissivity is denoted as, and it is the value varies from 0 to 1. The emissivity is a measure of how closely a surface approximately a black body for a which epsilon is equal to 1. For a substance, emissivity for some substance, that is vegetarian, water, skin, and the building materials, pines, rocks, glasses, carbon, ceramics, and metals and polished metals. Absorptivity, reflectivity, and transmittivity. The fraction of irradiation absorbed by a surface is called absorptivity, and the fraction reflected by a surface is called reflectivity. The fraction transmitted is called as a transmittivity. Reflectivity. It is a actual or irregular reflection. In specular reflection, the angle of reflection equals the angle of incidence of the radiation beam. In diffuse reflection, the radiation is reflected equally in all directions. Absorptivity. The absorptivity depends upon the temperature of the source at which a incident radiation is originated. For example, the concrete roof is 0.6 for solar radiation and 0.9 for surrounding radiation from trees and buildings, that is a 300 Kelvin. It is a diagram for absorptivity. Kirchhoff's law. The total hemispherical emissivity of the surface at a temperature is equal to its total hemispherical absorptivity for radiation coming for a black body at the same temperature. Glass transmits over 90% of radiation in a visible region, and it is practically opaque to the radiation in a longer wavelength range. But the entire radiation emitted by a surface at a room temperature falls in the infrared region. Consequently, glass allows the solar region to enter but not allow the infrared radiation from the interior surface to exit. This cause of rise in interior temperature is known as greenhouse effect. It is atmospheric and solar radiation. View factor in a plane surface, convex surface and convex surface. It is a view factor for 3 types of surfaces. It is a radiation occur in a small cavity or plates or cylinders and spheres. It is a radiation heat transfer in 2 surface enclosures. There is a 2 surface. It is a large cavity and the infinitely large parallel plates. It is a radiation occurs in a spheres and cylinders. It is a radiation occurs in a shield. 2 types of shield is there. In between we are having a shield, 2 types of plates, and in between we have a shield. From this the radiation occurs. We can see from this. Thank you.